Hey everyone, it's Mr. Canfield. Today we're going to be looking at 7-3 in Algebra 1. So this is multiplying special cases. So we have like 4 examples to look at today. So here's the first one. What if you see this? X plus 3 times x minus 3. You might be like, Mr. Canfield, we already did things like this. Correct, we did. It's just 2 things multiplied together. Let's see what happens. So I'll do the box method for this one, and then for the next example, I will do the more traditional method, the double distribute method. So draw my box, draw the box, Let's see, x times x. That's x squared, and x times minus 3, that's minus 3x, plus 3 times x, that's plus 3x, plus 3 times minus 3, well, positive times a negative is a negative, and 3 times 3 is 9. Okay, so normal. Combine my like terms. Let's see, x squared doesn't have any friends, so x squared comes down. Let's see, the minus 9 doesn't have any friends, so the minus 9 comes down. When I look at my like terms here, I have negative 3, I have positive 3. What's negative 3 plus 3? It's 0. That means there are 0 x's left. Turns out there's no middle term, and it's just x squared minus 9. Oh, that's kind of weird. All right, let's look at another one. I'm going to look at 2x plus 7 times 2x minus 7. All right. So I'll do the traditional way. You can do the box way for this if you want. Both ways work. If I do 2x times 2x, well, 2 times 2 is 4. X times x is x squared. Then 2x times minus 7, well, 2 times 7 is 14. There's an x, and it's a positive times a negative, so it's negative 14. Then we'll switch over to our plus 7. 7 times 2 is 7, well, 7 times 2 is 7 times 2. Good job, Canfield. It's a positive times a positive, so it's plus 14, and there's a single x between them. And then 7 times 7 is 49, and it's a positive times a negative, so it's negative. And, oh, interesting, okay. When I'm combining my like terms, let's see, 4x squared just comes down. But look at this, minus 14x plus 14x. It happens again. 4x squared minus 49. There is a secret shortcut that you can do with a problem like this. So I know I said there will only be 4 examples today, so this is going to be a fake example. Let's call it 2A. So now that you've had a chance, x plus 3, x minus 3 is x squared minus 9. 2x plus 7, 2x minus 7 is 4x squared minus 49. What do you think 3x plus 5 times 3x minus 5 is? We actually can do this without doing any work if you picked up on the pattern. So pause the video if you want to try to figure out the pattern for yourself. I'm going to spoil it in 5, 4, 3, 2. Now, okay, so the spoiler is, see how it's the exact same thing, but one's plus, one's minus? This creates a special situation where you just take the first one and you multiply it by itself, so you just square it. So 3x times 3x is 9x squared. And 5 times 5 is 25. And you just throw a minus in the middle. Only works when they're perfectly the same and one's plus and one's minus, but it always happens that when you do the work, the middle terms cancel out. It makes something called the difference of 2 squares, because 25 is a perfect square and 9x squared is a perfect square. So when we move into factoring later, this is going to be a special case that we notice. But yeah, so that's the first big idea, and here's the second big idea. So we'll do 2 examples of these. Let's say we see x plus 8 with a squared on the end. There is a common misconception that people have with this. We've looked at stuff like this before, and we just distributed the 2 to everything. But I want to remind you, ladies and gentlemen, plus is evil. Plus is awful. Adding and subtracting ruins everything. It's the hardest thing in math. Not really, but it's bad. So this plus messes with us. We can't just say this is x squared 64. No, that plus, so x squared 64 plus, no. Let's talk about y. X plus 8 squared means x plus 8 times x plus 8. And what I would recommend is, especially when we're doing problems like this, anytime you see a square like that, rewrite it like this and get rid of the original so that you remember, oh yeah, I got work to do. And now you can do either way. You can do the box way, you can do the double distribute way. I'm gonna do the box way for the first one just to keep it consistent. So I'll put my x plus 8 up here, I'll put my x plus 8 down here. X squared, x times 8 is plus 8x. 8x again, okay, 8 is 64, so we get x squared. Now this time, instead of canceling out 8, they actually double up. 8 plus 8 is 16. And then there's a 64 on the end. So, yeah, okay. Now look at 4. And then the final example after 4, we'll do a 4a. I'll show you the trick that if you recognize that there is a way to do these in your head, though for a lot of you, I feel like doing it in your head is going to be like, no thanks, I just want to do the work. And I totally get that. I'm never going to say you have to do the work. All right, so let's say we get, let's just get a little bit more fancy. No, we don't need to. 2x minus 4 times 2x minus 4. Canfield, you were supposed to write this differently. You were supposed to write 2x minus 4 with a squared on the end. That's what the problem's supposed to be. 2x minus 4 squared. And what it means is 2x minus 4 times 2x minus 4. I wrote this the first step because I'm so used to, as a teacher, every time I see one of those squares, I rewrite it. So let's start over. Hey guys, it's Mr. No, just kidding. So let's say we got this for the problem. The first thing we would do before we even do any more thinking is go, oh yeah, that means to write it twice, boom, okay. Now here's the real problem. All right, so 2x times 2x, that's 4, and then x squared. 2x times minus 4, 2 times 4 is 8, and it's a positive times a negative, so it's minus, and there's an x shared between them. Or sorry, 1x like total between the two of them. Same thing here, right? Minus 4 times 2 is minus 8. There's an x. And then minus 4 is plus 16. So I get 4x squared minus 16x plus 16. So here's 4a. This is our little secret shortcut. If I ever see something, so let's say I see 3x minus 6 squared. So you might notice that for 3 and 4, I did end up with the first thing squared and the last thing squared. That did actually happen. So like 2x minus 4 squared, I did end up with a 4x squared, and I did end up with a 16. Oh, and the minus turned into a positive. So I know for this, I am going to end up with, well, 3 times 3 is 9. And then 6 times 6 is 36. Like, I'm going to end up with that, but I have to figure out what's going to happen here. So if I look at my middle term for both of these, one was plus, one was minus. Oh, that came from the sign originally. Okay, so I know that this was minus, so I'm going to write minus. But where did 16? They both were 16. That's a coincidence. Oh, it came from 8 and 8. They both were 8 and 8. Where did the 8s come from? Well, this came from x times 8. This came from 4 times 2x. Oh, okay, so it's going to come from these two multiplied together. So what's 3 times 6? 18. There's going to be two 18s. 18 is 36 with an x. So that is the special format. If we see a squared, we can square the first, square the last, multiply them together. So the way that we would actually talk about this is we would say if it's a plus or minus b squared, you square a, you square b, you take a times b, and you double it. And whatever the sign is here, it's always going to be the sign there, and then this is always positive back here. So that's the format. That's the more advanced. Remember the A examples for this today, those are both the more complicated ways of thinking about it. The more complicated way is the fastest way, but you don't need the more complicated way. You can do the work, get the answer, no big deal, and that's it. So enjoy, have a great day. I love you very much, and I'll see you next time. Well, I'm not. Why do I say I'll see you next time? Who says I'll? Why does everyone say I'll see you next time? I'm not looking at you now. So wrong for me to say I'll see you if I'm not looking at you now. Bye.